Hey everyone, this video is to talk about graphing radical functions. More specifically, we're going to be focusing on the square root parent function and the cube root parent function. So the first thing I want to talk about is the graph of each of them. So going into our graphing calculators into the y equals screen, we are going to type in the square root of x. So that's second x squared, and then your variable button x is right here. And what we can see is we have this function that kind of trails off on one side. So to find our y values, we are going to look at our table. If you look at any of the negative values, you're going to see error. The reason being is because you cannot take the even root and square as an even number of a negative value. It gives you an imaginary. 0 is at 0, 1 is at 1, 4 is at 2. We choose x values that are perfect squares so we can find integer y values. So 0, 1, 4, the next perfect square would be 9, square root of 9 is 3, and so on and so forth. I could do 16 and 4, 25 and 5, etc. So we're going to graph these points, 0, 0, 1, 1, 4, 2, we can even graph 9, 3. And it's going to continue off in this direction. Our special point is going to be that beginning point, 0, 0. Remember, domain refers to the x values. So the directions I'm continuing to the right and to the left. Here I am continuing to the right forever. That's going to positive infinity, which always gets written second because you always write your smallest number followed by your biggest number. Because we can never actually touch at infinity, we put a parenthesis. Our value on the left is going to be our smallest x value, so I come over here to the point all the way on the left, x value of 0. Because you're physically touching at 0, we put a bracket. Range refers to the y values that we have. So whether I'm continuing up or down or both directions. As I move to the right, I'm continuing up forever. Up is a positive direction, so I'm approaching positive infinity. Smallest value over here is the lowest point on the graph, which is this point, which is a y value of 0. Now for our cube root function, we go back into the y equals, we can get to the cube root by pressing the math button, coming down and choosing option 4, and then putting an x in the middle. And you see kind of this very stretched out S-shaped graph. So if we look at our table, now we can have negative x values because you're taking an odd root. Remember, odd roots work really, really nicely. You can take odd roots of negatives and positives. So the cube root of negative 8 is negative 2, of negative 1 is negative 1, 0, 0, 1, 1, and 8, 2. And we can graph those as well. Kind of get that stretched out S shape. Our special point is going to be this point in the middle, kind of where it turns and creates the S. We're going to let 0, 0 be our special point. Domain, I'm continuing to the left forever as I move this way. That's a negative infinity. That gets written first. I'm also continuing to the right forever, so I'm also continuing to positive infinity. For the range, as I move left, I'm also going down forever. That's negative infinity. And as I move right, I'm going up forever. That's positive infinity. For our purposes, a cube root function will always have the domain and range of negative infinity to infinity because you can always take an odd root of any number. For our purposes, we are going to graph the square root function using 2 points, 0, 0, and 1, 1. Obviously, we can continue further, but we're going to let these be our key or our parent points. For cube root, we're going to do 3 points, -1, -1, 0, 0, and 1, 1. We're going to start by talking about translating. If you remember translations are when you add or subtract a number. And think back to the beginning of the year. There were 3 questions that we asked ourselves. The first one we asked was, is the number inside or outside? In this case, inside is going to mean underneath the square root or the cube root. It's going to be underneath the radical or inside the radical. If it's inside, it's moving on the horizontal, and horizontal is always counterintuitive. It's the opposite of what you think. Outside is vertical. Vertical is really nice because it's what we expect to happen. So starting with this first function, square root, so I know I'm going to be using the parent points 0, 0, and 1, 1. And then we want to list the transformation. This plus 5 is on the outside, so I know it's vertical. It's a vertical translation because it's what we expect. When you see plus 5, you should move in a positive direction. We go up 5 as opposed to down 5. This vertical translation is going to affect the y values, so we're going to add 5 to the y's. X's stay the same as 0 and 1. In the y's, 0 plus 5 is going to give us 5. 1 plus 5 is going to give us 6. And then we just graph our points. For domain, we're talking about the x values. I'm continuing to the right forever. That's a positive infinity. My smallest x value is the point all the way to the left, which would be here. This point 0, 5 has an x value of 0. The range then, I'm continuing up forever. That means I'm going to positive infinity. The smallest y value is going to be the lowest point on the graph, which here is at 5. You are able to check every single one of these problems in your graphing calculator, but I still need to be able to see your work. The second example, once again, I'm dealing with the square root function. So that's values 0, 0, and 1, 1. This minus 2 is on the inside. I know inside is horizontal. So I have a horizontal translation. Minus 2 makes you think to move negative, so to go left 2, but it's counterintuitive, so we're going to go to the right 2, which means on the x's, I'm going to just add 2, x plus 2. So 0 plus 2 is 2. 1 plus 2 is 3. Y values are going to stay the same, 0 and 1. Focusing in on domain, you are going to the right forever. That's positive infinity. The lowest x value, the point all the way on the left, is right here, an x value of 2. For the range, we're going up forever. That's positive infinity. Smallest y value is the lowest point on the graph. That's a y value of 0. Example 3, you notice we have 2 transformations here, so we're going to start with our parent points, 0, 0, 1, 1. We'll start with this plus 3. That plus 3 is on the inside, so it's a horizontal translation. Because it's counterintuitive, when it's plus, you're really going minus. That's left 3. This minus 6 is on the outside, so I know that's a vertical translation. It's what we expect, so when you see minus 6, we are going down 6. Remember, I want you to list the direction, left, right, up, or down every time. So left 3 means I'm subtracting 3 in the x's. Down 6 means that I'm going to subtract 6 in the y's. So in the x's, 0 minus 3 is negative 3. 1 minus 3 is negative 2. 0 minus 6 is negative 6. 1 minus 6 is negative 5. And then we graph our points. We have negative 3, negative 6, negative 2, negative 5. Still keeping that same shape every time. As I continue, I'm going to the right forever. That's going to a positive infinity. That means my point all the way on the left here, this x value is negative 3. The range, I'm continuing up forever. That's a positive infinity. That means the lowest point, the smallest y value, is going to be down here at negative 6. It's based kind of off of that special point that we talked about. All right, last example, this time using the cube root function. Now, because it's cube root, we want to start with 3 parent points. So negative 1, 0, 0, and 1, 1. This minus 1 is on the inside. It's a horizontal translation. It's counterintuitive, so I'm going right 1. That 2 is on the outside. It's a vertical translation. It's what we expect, so we are going up 2. That means to the x's I'm going to add 1. To the y's I'm going to add 2. So in the x's, negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. In the y's, adding 2. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. Now, the only problem when you graph the 3 points on the cube root function is it kind of looks like it's going to be a straight line. Remember, it's that stretched out S shape, so do your best to connect them kind of like that. My domain, I'm continuing to the right forever. That's going to positive infinity. I'm also continuing to the left forever, so that's negative infinity. For the range, as I move right, I'm going up forever, positive infinity. And I move left and down, that's a negative infinity. Remember, cube root function, domain and range will always be negative infinity to infinity. Last thing that you have at the bottom is, once again, a little explanation. Horizontal moves left and right. You can see it's on the inside and underneath, and it's counterintuitive. You see minus, but you go right. You see plus, but you go left. Vertical, up or down, that number being added or subtracted is on the outside, so it's not underneath the radical. Plus is up, minus is down because it's what we expect.